Hello, I welcome you to the next tutorial for microwave-based non-destructive testing. Today we will see a second example for the three-dimensional localization of defects using the FMCW method. In the last tutorial video, we have already learned how to localize defects in all three dimensions by using the FMCW method. Especially the depth information is obtained by transforming the propagation delay into an easy measurable frequency difference. We had seen an example by testing a sandwich made from GRP, PU foam, GRP, and that was very impressive. Today we will see a second example, not less impressive. And this is also prepared by Dr. Stefan Becker from Becker Photonic GmbH, and I thank him very much for making that available to us. Here we see the constructional drawing of a cooling box made from aluminium nitride. This cooling box is used for heat removal, for example, from power electronics, which is mounted on top of this box. Here in the top view, we have the inlet and the outlet of the cooling medium, either air or water or another cooling liquid. The cooling medium washes around these posts to ensure a good heat transfer. The box is made of two half parts which are opposed and soldered together. Thereby it is essential that the connections between the top parts and the bottom parts of the posts, I show it here, that these connections are of high quality. After soldering, these connections cannot be inspected visually. A traditional test is only possible with X-ray CT, but that is rather complicated because of the necessary safety precautions. Here we will see that microwave testing with the FMCW method will do this much easier. We should note the following. Aluminium nitride is a good heat conductor, but it is electrically insulating. And so components of it are suitable to be tested with microwaves. Now we will see a series of views, C-scans, through various planes in this box. This view graph shows a C-scan through the top plane of the box. Only a shallow blind hole in the outer surface can be seen. This view graph shows a C-scan a little bit deeper, so that almost only the uppermost parts of the inlet and the outlet can be seen. The next deeper plane is a view through the top part of the box. All the posts can clearly be recognized. Most interesting, however, is a C-scan through the solder plane, which we see here. The posts occur in different variations. Some are rather dark, and some have white spots which show pores in the solder. We have a rather high spatial resolution in these images. This is reached by using FMCW with rather high frequencies. It is around 300 gigahertz or around wavelengths of 1 millimeter respectively. In the last view graph, we have a comparison of solder plane images from microwave FMCW on the left-hand side and X-ray CT on the right-hand side. The resolution of the X-ray image is somewhat higher than the FMCW image. But the essential findings, and that is pore or not pore, can be taken from both images likewise. And so far we have an excellent coincidence. We have seen another impressive example for what microwave testing with the FMCW method can be used. Before coming to an end for today, I want to give you 2 recommendations for books which describe microwave testing in more detail than I can do it in these video tutorials. The first book, Microwave Non-Destructive Testing and Evaluation Principles, is written by Zoughi and already published in 2010. It describes basics and a lot of applications of microwave testing, which to a large part are based on work in Professor Zoughi's university laboratory. The second book, Microwave Non-Destructive Testing and Evaluation of Fibre-Reinforced Polymer Composites, is written by Dr. Zhen and is only recently published in 2025. It describes microwave testing in a broader view than the title suggests. The book also describes side technologies as microwave techniques and also briefly FRP technologies. It also explains new methods for the evaluation of raw data from microwave testing. So far for today. Thank you for watching. Goodbye. See you next time.